The test go? Was it okay, difficult? I know we could not cover all the topics, but were we able to do okay? Okay, Riddhi, I could not get your response, but I assume that's fine. I mean, we can take it offline. I would not want to put that on a video here, but I hope whatever we learned that was of some use. Yeah, Riddhi? No. I can barely hear you actually. Not sure if it's a network issue or can you hear me okay, better? Do you want to log back in? I mean, log out and join back again?
Mhm.
Yes. Can you hear me now?
Yes.
Okay. All right. So I was just asking, how did the exam go? Was it okay? Whatever we learned, was that of some use using
Yeah, the
exam?
exam went pretty okay. We'll get the results on Monday.
Mm-hmm. Okay. Okay. Good. All right. So what are we going to learn today? So that's the question I was asking myself, and the same question I'm going to ask you today. So Daddy had sent me some, no, all the syllabus. So there's one called Unit 2 FDF, which means fractions, decimals, and percentages. That's one chapter we can pick up,
Okay.
or we can go to chapter number um chapter number 14. Sorry, chapter number, it's chapter 14. Yeah, it's chapter 14 saying mensuration. So which one you want to start with?
Maybe fraction decimal percentages.
Okay, okay, that's fine. All right. So let me share my screen quickly. And this topic we will try covering in two classes. Okay. Let's not
Okay.
hurry for doing it one class and then uh, that is not useful. Okay.
Yeah.
So so let's spend some time on wrapping our head around what do we mean by FDP, fraction decimal percentages, and how they are relatable. Yeah.
Yeah.
So you can see my white screen, right?
Yes.
Okay. So fraction, decimals, and percentages. And percentages. I'm just trying to be lazy to write less. Okay. So fractions. Um, Again, it goes back to the original thing that we all learn in a very early stage of our education, right? The number line.
Yeah.
You have 1, 2, 3, 4, 6, 5, 6, and this side you have negative values, minus 1, minus 2. So whenever we talk about a whole number or a natural number, we are talking about these numbers. Natural number are all positives. Zero into it becomes a whole number, and then include negatives, that becomes integers. But
Okay.
here, what we see essentially is all these numbers are complete by itself. It's like giving one apple to somebody, borrowing two pens from somebody, giving
Okay.
$100 or €100 to a friend, having a party and spending, let's say, $200 or €200.
Okay.
All these are complete numbers by itself. You don't end up dealing with any partial values. So when I say partial values or fractions, there's a striking difference between 1.1 and 1 or 2, right?
Yeah.
These numbers have, this cannot be used in 1 unit. Let's say if I'm talking about $1.1 or 1.1 euro, I'm essentially talking about one complete dollar and part of a dollar.
Okay.
So these are like partial numbers. So it has some complete thing to it and some partial thing to it. Let's say if I talk about, I'll give you 0.25 apples. I'm not going to give you one apple for sure. I'm saying that I'll break apple into multiple pieces and I'll just give you one piece of it. Yeah. If I
Yeah.
say I need to borrow 3.75 euros from you, there are two parts to it. This is the full part, which is easy. And this is when you will start collecting the coins and then add it together and say, okay, here's 3.75. Yeah.
Okay.
So all the fractions that we talk about, these are essentially something like a compound number. I mean, again, I'm making it up. And there's no term called compound number that I've heard about, but there's a term called mixed number
Yeah.
or something like this. So there are different varieties of numbers. See, people say, "Oh, I know numbers," but actually, it'll be unfair to, or it'll be very early to say, yeah, somebody knows about all different types of numbers that we deal with. Even I would not dare to claim that I know all types of numbers. That is not possible because there's so much variety in it. The number system has evolved over time, and that is how we learned first the complete numbers by itself, and then we categorized them into different buckets. Then we came across these partial numbers, and
Mm-hmm.
then life became more interesting when we started looking at something like this or something like this. This looks a very cute fraction, but actually, when you convert that to decimal, you will not find an end of it. It
Yeah.
just goes on. So that is where you come across those, the recurrence within the number. So again, not trying to complicate this. What I'm trying to say is the different varieties of numbers that we deal with, and fraction is nothing but one type of it. So whenever we say fractions, we are talking about fractions, as in a part of something. So if I say one, that is a whole number or
Yeah.
a natural number. If I say this is fraction, meaning I'm splitting something into multiple pieces, and none of them are essentially complete in itself. Yeah.
Mm-hmm.
And this kind of problem happens when we deal with a bigger family, right? I mean, I'm not sure, but I think I know about you that you are two siblings. When we were small, we were like I was like I had four more siblings. I have four more siblings, right? So we are five, and then we were living in a joint family with around almost like 20 kids together. So if we, let's say, buy a bar of candy or a chocolate bar, you can imagine how
Yeah.
interesting that used to be to divide it equally among all of them. And,
Yeah.
and that was the first practical scenario that we came across, that okay, I have one bar, I have to distribute among 10 people, so everybody gets 1/10 of it. So that is the first practical, relatable situation that we came across. I'm sure between you and Siddhi also same thing, right? Let's say tomorrow if daddy mommy decides to buy only one bar because you have not tested it before, so
Okay.
he's not wanting to buy two. He'll say, okay, let's buy one, and you guys both share. And then if we find this good, next time we'll buy two.
Okay.
Yeah. So that is a practical scenario that we come across. And any and every math that we will learn or whatever I will try teaching you, I'll make sure that you're able to relate to that. You go to a supermarket, you buy something, somebody says, okay, this is 3.37 euros. Yeah. Or
Yeah.
3 dollars. Three is fine. This is when the problem begins. Yeah. Now you have to start collecting those small coins and then add it together. Or let's say if you have $10 note and you're buying something for 6.39, imagine how interesting it is for the person on the store in the store to give you the change.
Yeah.
So that is what we essentially deal with. Now let's look at fractions. So any fraction, when we say, first thing that should come to our mind is it is part of it. If I
Yeah.
say 2, it's whole by itself. That's why
Mhm.
it belongs to a whole number family. And if I say this is to be divided among 6 kids, that is when it becomes fractions. A fraction. So simple understanding of fraction is something that is divided among multiple people
Okay.
or a part of it. So now let's look at some scenarios. Why I start with 2 always, I don't know. 7 by 9. And somebody says, okay, fine. Let's say we go to a party where there are two aunties. Okay. One auntie has 7 oranges and there are 9 kids in the party. Okay. She has 7 oranges and she say, okay, I have to divide this equally among 9 kids. Another auntie came and she said, okay, I have 5 chocolate bars and I will also distribute it equally among all the kids.
Okay.
Or let me not complicate this. One auntie had 7 chocolate bars, and the another auntie had 5 chocolate bars, and there are 9 kids in the party.
Yeah.
So this auntie divides it among all the kids. This auntie divides it among all the kids, and you are one of the kids. So you are trying to figure out how much I'm getting. I'm getting 7 by 9 from one auntie, 5 by 9 from one auntie. What is the
Okay.
total that I'm getting? This is when you end up adding these fraction addition. Yeah.
Yeah.
And if I may ask, are you very comfortable with this kind of fraction addition?
Yes.
Okay. Can you do it real quick and tell me how much it is?
That'd be 12 out of 9. Or if
12,
you simplified it, it would be 3. Sorry, 4 to 3.
4 to 3. You said what will be the sum of these two?
Sorry. So that would be. Well, first you have to make the common denominator. That would
Uh,
be 11 out of 9.
this will be uh, 11 of 9. So it will be okay, 11 of 9. Yeah. That is a quick method. So you made the denominators denominators common, so you multiplied by 3 and you had to
Yeah.
multiply by 3 here also, so it became 6 by 9, and then you added the numerators and it became 6 plus 5. Okay, yeah, that is the smart approach, and that's quick. Now oh, sorry, if this is the case, how much that will be? So okay, let me not ask you stupid questions. So the one approach that you said, if I'm dealing with two numbers, I will make sure that denominators are common, and then
Yeah.
I go ahead and do it. Now here in this scenario, I have 7, 8, and 9. So you have to basically find out common denominators. And what do you do for doing it?
The
You,
lowest common multiple.
LCM, yes. So you will find out the LCM and then do all the magic. In simple terms, let's see if I have to add or subtract, let's say 7 minus 4 by 3. If I have something like this to be done, or even if it's a plus, doesn't matter. First thing always is the most orthodox method for this is you find out the LCM for all the denominators, meaning the
Yeah.
smallest number that is a multiple of all. So you find out, okay, find 8, 7, and 3. Let's do the LCM. We pick up the smallest number, 8. 8 doesn't come in the table of 3. 3 1 is 3, 7. Then I pick the smallest number, 1, excluding 1. So I go to 7. 8 doesn't come in the table of 7. That remains unchanged. 7 1 is 7. And then 8. So my LCM is 3 times 7 times 8. Right?
Yep.
So it becomes 168. Yeah. 8 7 is 56 into 3. So I think
Hmm.
that's what it is. Yeah. So I got, so then what you do is, I know these are things that you would have done 100 times before, but I'm just doing a recap, right? So that
Yeah.
so it becomes 168, and then you pick up the first number. And when I said plus or minus doesn't matter because my approach doesn't change. If I have three numbers to be added, if I have six numbers to be added, or four numbers to be added, two numbers to be subtracted, doesn't matter. I'll just write them down like the way it is written right now, and then I will do the same thing. Find out the LCM of all the denominators, and then start my magic. Right. First thing is 8. Now, how many times of 8 comes as 168? The answer is 21 because 873, that's what we multiplied. So, no, 21, and then multiply that with the numerator, which is 1. One bracket complete, one number done. Then we go to the next one, pick up this one. How many times of 7 makes 168? I know that it's 8 times 3, 24. And then multiply that by numerator. So this is this. Plus third number, 3. How many times 3 is 168? We know that it will be 56 because 873, that is what we multiplied, right? So 56 multiplied by 4. And then we just do the multiplication, break the brackets, and that's what we get the answer, right? So this is the most orthodox method. And what you did, that is the smarter way when you are dealing with a smaller option, right? Let's say if you have to do 2 by 7 plus 1 by 9, then you know that, okay, fine, I don't want to do all that magic. I just know that I have two denominators, and find out the LCM, which is 63. So multiply this guy with 9 both ways, this guy with 7 both ways,
Yeah.
and then 7 times 9 is common, so 63, and then here 2 times 18 plus 7. So and that's how. But essentially you're doing the same thing. This is just helping you save time because you knew that there's a small number, so I can do it faster. But otherwise the underlying concept is the same. You did the LCM and then did the same approach basically. So whichever works faster is okay. Now, so fraction part we understood, but why we are learning fraction, decimal, and percentage together, right? Because they are related. If I say 1 by 2, I can have an decimal equivalent of this one, correct?
Yes.
And that is zero point 0.5. So if somebody says 1 by 2, I can assume this is 1.5, and I can, let's say if somebody says 1 by 4, we know that it's 0.25. So if I have to add these two, I can simply add these two decimals, or I can add these two and then find out the decimal, whatever works for us, right?
Yeah.
So there's always a decimal equivalent of any number that you talk about. Let's say if you have, and one more theory I want to give you before we proceed, and that theory is fraction is our best friend. At least it is a best friend of mine. What does it mean? If I have to deal with different types of numbers, meaning let's say one mixed number, one whole number, one fraction, one decimal. Okay. If I have to add this kind of a number, or add this and this, subtract this and add this again. If I am dealing with four different types of numbers, right? This is a mixed number, this is a whole number. Come on, what happened? This is a whole number, this is a fraction, this is a decimal. If I have four different types of numbers, trust me, there's one type that is easy, and that is what we should lean on. We should basically know it's like adding kilometer with meter with centimeter.
Okay.
So what do? We convert everything into one unit and then we add them together so that we get one answer. Okay. Same way here, if you're dealing with different types of numbers, the easiest way for us to do the calculation would be first convert them into one, bring them into one family, and then you can deal with them with much ease. Let's say if this becomes, I'm just making it up, okay? If this becomes 125, this becomes 2, then becomes 0.33, it is 0.25. It's easy to add these kind of numbers, right?
Yeah.
Or second option is, if I convert this into fraction. 2 I can always write this as fraction. This is already a fraction. And this I can convert as this, or it becomes
1/4.
1 over 4. Now everything is in one family, right? One type of data. So math always expects us to do one, convert things into one format and then deal with it. That's the easiest approach that we can always take, or we
Yes.
should always take. If you end up in a situation where, let's say, you go to a grocery store and you buy potatoes, tomatoes, cheese, and let's say fish. I believe you eat fish.
Yes.
Okay. So if you're buying these four things and the storekeeper says potato is $2 per pound, tomato is €3 per pound, uh, fish is 2.8 dirhams per pound, and then the cheese is, let's say, 100 rupees per pound. That is not something that you would want to do. We never
No.
carry four different types of currencies. Neither our cards support that kind of thing. And if it does, it takes you, it makes you pay additional currency conversion fee, right?
Mm.
So for the sake of simplicity, math is always about converting things into similar unit and then do the operation. That is
Mm.
what would be our goal always. So whenever we come across any situation, any problem, any math, any question which requires us to deal with multiple units, our first attempt should be to convert them into one form, one format, one unit, and then deal with it. And trust me, this is not something new that I'm telling you. I'm sure you would have heard it 100 times, right?
Mm.
So now let's look at a sum, and if you want to solve it, I'm talking about 2 1 by 9 minus 1.6 plus 2 over 8 minus 1. So going back to the theory that I was giving just now, your first attempt has to be convert them into one form, and that could be in a fraction form, in a decimal form. But as I enforced, or as I made you believe, fraction is our best friend. So when you're dealing with different types of numbers, trust me, you would want to convert them to fraction. That'll be easiest, unless the numbers are simple enough, right? I mean, if you look
Mm.
at 2 by 4, you know that it's 2 by 8, it's 1 by 4 or 0.25. But how about this, right? So that's why our attempt should be, whenever we are dealing with mixed number scenario, always try converting that into fraction. Now tell me, how much is this one?
That'll be 19/9.
19 over 9. And simple thing, right? Clockwise movement. That's what happens. You multiply these two, add this one, divide by this. This is a complete clock. You
Mhm.
start from here, you come all the way till here. Multiply these two guys, add this one, divide. So you have multiplication, addition, and division here in this operation. 2 9 is 18 plus 119 by 9. So that same thing. I'm just giving a different color to it. Yeah. Now convert this into a decimal, fraction.
Uh, 16/100.
No, 16 over 10. You'll
Oh,
ask me why. You'll ask, yeah, no, no. So see, this is again. These are some of my, what do you call, derived methods for which I had used for my own learning, and now I'm cascading that to all my students. Right. So same thing here. Let's see if I have. Let's go back to let's go to another situation. Let's play with this. If I have, let's say, this to be converted into decimal. I'm not sure if I have told this to you before, but let me repeat myself if I have done so. I will simply write the number as is. Okay. I'll forget about the decimal. And then I have one decimal. So I'm acknowledging that by writing 1. And then I will count how many digits I have after this decimal. I have only one digit. So 10. That's it. Now you will ask me, how about this? Same thing. I will do it in the most dumb way possible. I'll just write the number as is, not worry about the decimal and everything. And then decimal, there's one decimal, and any decimal will not have more than one decimal. So you always write one. You will never
Yeah.
have a number like 1.23.645. This is more like a phone number rather than being a number. Okay.
Okay.
Yeah. So you'll always have one decimal in any decimal number, right? So you write one for that, and then you count how many digits you have after decimal on the right hand side. You don't count this one. Okay. You're counting
Okay.
this one. So then you count one, two, and three. There are three digits. So you'll put as many zeros. That's it. Yeah.
Okay.
So that is the most. I know it's a very childish way of doing it, but that is how I've been doing it all through, and I don't think I'm going to change it anymore. So if I have somebody says convert them to fraction, what will be your answer? You will write
Um.
this as is, and then
Yeah.
put a one for decimal, and then count the digits on the right hand side. Two digits, two zeros. Simple.
Okay.
Now we know that zero before a number doesn't hold any meaning. Yeah, I can have as many zeros. Yeah.
Yes.
So just to for the sake of saving some space on my piece of paper, I will knock off that zero. So that's how it becomes.
Okay.
So if you're doing that in a step-by-step manner, let's say if somebody says convert 10.24, or no, I'll not do that. 0.017 into fraction. I will, my first step would be, okay, fine, whatever number I have, I'll write everything.
Yeah.
Then put one for the decimal and count the digits. Three digits, three zeros. Done. Now in my next step, I since I know that this is what it is, so zero zeros before the number doesn't make any sense. I will knock
Yeah.
them off. I'll say, okay, this is equal to this. So always, when you're solving sums, right? Always try to solve it like a story. Okay, this is the story I'm telling. This is my number. I have to convert into decimal. Sorry, to fraction. So this is my first thing I will do based on the approach that we follow, and then this zero has no meaning, so that is equal to this. So this becomes a three-step thing, but the chances for error is very little. Yeah.
Okay.
So always try practicing whatever you do. Always try to practice. That'll get into the habit of telling story, and you would also know if you have to do review where you have to go. Okay. All right. So going back to the previous sum, this part we converted to fraction. This we converted to fraction as well. Yeah. This is already a fraction. Yeah.
Mm-hmm.
And then the number. If I have a whole number, I can always put a one as a denominator, and then everything looks like from the same family. Yeah.
Okay.
Everything is a fraction now. So you started with this, you converted to this. So this is your second step. So you are saying this equals this. And
Yeah.
then you will go ahead with your next step where you will find out the LCM of the four denominators and do whatever we were doing. Correct?
Yes.
Now, let me reverse something that we were doing. If I have 1.018, we know how to convert that to fraction. Okay. That we just talked about. Correct? That
Yes.
this is what it will be, and then I will put a one for decimal and then count the digits, three digits. Done deal. Now how about reverse of it, meaning I have a fraction, so we know how to convert a decimal to a fraction. Let's say tomorrow you have to solve a sum where where you want to convert everything to decimal, because you know that, okay, if I have to add 0.54 with 0.39, it's easy, it's simple sum. I'll say 943 538 plus 19. This is very easy, right? This is a one step process.
Yeah.
So, if you have to convert a fraction to a decimal, let's say 1/8 to a decimal, how much that will be?
Well, you have to 1 divided by 8.
Yes.
Um,
Here also I'll tell you one interesting, my own derived theory. Have I told you about the chicken egg thing?
Um,
We did? No. Okay. So now, okay, let's. So you have to divide it. You tell me how you would want to do it. Then I'll tell you my theory.
will you write a 0 first? Because 1 is less than 8.
Uh-huh. So you'll add a zero here or here. Okay. Let me make it even simpler. Okay. Let's start with the chicken thing, chicken egg thing. Okay. Or yeah. So my I call decimal as a chicken
Okay.
during division. Okay. When I'm doing division, if I put a decimal, the decimal is like a chicken which lays one egg at every stage. Okay.
Okay.
Decimal is a chicken that lays one egg at every step of division. Okay. So if you like chicken, you will like division. Okay. Okay.
Okay.
Now, as I said, decimal is a chicken that lays one egg at every step, meaning as soon as I put a decimal, it laid one egg. Now, see, 10 is bigger than 8. Now we can start with our division. Yeah. Now you look at 10. 10 is bigger than 8. 8 1 ja 8, 8 2 ja 16. So we can only go up to 1. 8 1 ja. How much I got? Remainder 2. Now 2 is smaller than 8, but I have the chicken which is going to lay one more egg at the step. Now it is 8 2 ja 16. What is remaining is 4. Oops. 4. Now still 4 is lesser than 8. But I have the chicken which is ready to lay one more egg. 8 5 ja 40. Done. So if you remember what I mean, if you see here, whatever I said, the chicken, which is my decimal, is laying one egg at a time, only one egg at every step. Yeah.
Yeah.
If your calculation goes on, this chicken will keep on laying egg, one egg at a time. Let's do this. 1/7. Okay. If you have to find out the decimal value for this, same chicken egg story. You have to divide 1/7. Now you put a decimal that lays one egg. 7 1 ja 7. 3. You have a chicken which laid one more egg. 7 4 ja 28. 2 remaining. Chicken lays one more egg. 7 2 ja 14. 6 remaining. Chicken lays one more egg. 7 8 ja 56. 4 remaining. Chicken lays one more egg. 7 5 ja 35. 5 remaining. Chicken lays one more egg. 7 7 ja 49. 1 remaining. Chicken lays one more egg. 7 1 ja 7. And it goes on. So just by adding the decimal here, whenever you're dealing with a number, which is when the numerator is, or the number to be divided is smaller than the the number that is dividing it, that is when you use this one. Okay, the decimal. So this is how you convert a fraction to decimal, meaning when you're dividing a smaller number with a bigger number, you use this theory of chicken and egg to get your decimal value. Okay.
Okay.
So let me give you two sums. Okay. I want you to do it, not because I'm trying to see how correct you are. I'm just trying to see if this chicken egg story theory has reached you successfully or not. Okay.
Okay.
Can you do these two and let me know? And if you get the right answer, I mean, regardless of whether you get right answer or not, we will anyways do it. But I'm just wanting you to spend 5 minutes, do it, and then we'll do it the same chicken egg way.
Okay. The first one is 0.25.
Mm-hmm. Second one.
And uh, well, so far I have 0.428.
Hmm. Did
Um,
the chicken egg thing help?
a little, yeah.
So 2 by 8, 0.25 is perfectly fine. 3 by 7 also, I believe what you're saying is right. Let's do the chicken egg thing one more time so that now I want to bore you enough so that it gets stuck with you. Okay. That's the goal.
Okay.
So 3 is smaller than 7. So I need to borrow, and my friend is chicken. As soon as I put a chicken here, it lays one egg. 7 4 ja 28. 2. Now chicken lays one more egg. 7 2 ja 14. 6. Chicken lays one more egg. 7 8 ja 56. Chicken lays one more egg. 7 5 ja 35. 5 remaining. Chicken lays one more egg. 7 7 ja 49. Chicken lays one more egg. 7 1 just 7. See. Chicken lays one more egg. 7 4 ja 28. And it will go on. So
Yeah.
if you once it came to 4, you will see the same thing repeating. Okay. It'll go in the
Okay.
same loop. Okay. But the good thing is I don't want to do this kind of math with a very loaded mindset. Oh, this is a tough sum. No. I will do it like a child. Right? But okay. Let me play with it. If somebody says find out uh, this same thing. If I have to divide 16 by 13, so we know that 13 1 ja 13 we can do. 3 is remaining. Now we are stuck. Now it has come to a point where we have to divide 3 by 13, and that is where we have to borrow zeros to make it bigger. And that is where chicken comes to our rescue. Yeah. Now the
Okay.
same story continues. 13 2 ja 26. 4 remaining. Chicken lays one more egg. 13 3 ja 39. 1 remaining. Chicken lays one more egg. Oh, we got stuck. Now, good thing with decimal is if you come to this point, the chicken will lay only one egg at a time. Okay, it doesn't lay two eggs. Okay,
Okay.
so in this scenario, if you need more zeros or more eggs, so it is like okay, you are giving one egg to the chicken, and the chicken gives you one more egg.
Okay.
So that is I mean, but one thing to remember is whenever you put a decimal, it just enables you to get one zero at a time, only one zero. If you need to add more zeros, then it's like a give and take. You give one zero to in the no this part and gives you one extra zero. So let's look at one more scenario, and then let's say you have to divide 3 by 1000. Okay, yeah. So you're trying to divide 3 by 1000. 3 is way too smaller than 1000. So that will not help. You want to borrow zeros to make it bigger, right? So
Yeah.
here, your first option is a chicken that gives you one zero. But this is not enough yet. So this is when you start trading with the chicken. Say, okay, chicken, I'm giving you one more egg. Chicken says, okay, you get one. I'm giving you one more egg. Says, okay, I'm giving you one more. Okay. Now, so one egg at a time is what you got from the chicken, okay, from the decimal. Now, if you want to add more zeros, now it is a much bigger number 3000. 1000 into 3 will give you 3000. Okay. So, this
Yeah.
now, if you have 0.003, one thing I forgot to tell you is you can add as many zeros you want before and after decimal. Okay, so you can add
Okay.
zero to make it look more complete. Otherwise, 0.03 it could be a little confusing, right?
Yeah.
So that's what you do. So here, if you have to convert a fraction to a decimal, this chicken egg theory helps. Or this is a common theory for any division for that matter, right? Let's say if you have to divide 1250 by 5, then it's simple division, right? So you will say, okay, fine, 1250 divided by 5. 5, you pick first number smaller. You can pick first two numbers, 5 2 are 10, done. 2, one number comes down, 5 comes down, 5 5 are 25, then comes a 0. Okay, I should not have picked up this number. Okay, let me pick another number because that will add another flavor to it. Yeah. So we did first two numbers, 5 to the 10, two remaining. 5 came down from above, that became 25. 5 5 are 25, and then this is 0. Then the last number comes down, 5 1 are 5. This is done. So this is my answer, right? But imagine a situation where there was no perfect answer. There was no answer in whole number. So if you're talking about 3 by 8 or 30 by 8, let's say, so that is when you'll say, okay, fine. So this chicken egg theory is extension of division actually. Okay. So
Okay.
what happens here? 8 3 are 24, 8 4 are 32. So I can go only to 30, 24. 8 3 are 24. What is remaining is 6. Now we are stuck. We have come across chicken egg story, right? There is no number left. So that is when you start with the chicken thing. Okay. Decimal makes it 60. 8 7 ja 56. What is remaining? 4. Chicken lays one more egg. 8 5 ja 40. So this chicken egg thing, right? There's nothing new here. I'm just trying to make it a little interesting. It is part of division. When you're doing division and you come across a point where the number that you're left with is smaller than the number that you're trying to divide it with, that is when you borrow the zeros by going in this direction by calling it chicken egg thing. Yeah.
Yeah.
So I know we touch different aspects of it, but in summary, we just learned if I'm dealing with multiple number types, it's always advisable to convert them into one. So, and that is where we looked at how do we convert the mixed number to a simple to a fraction. And that one common thing has to be a fraction because fraction is our best friend. Okay, when we are dealing with different types of numbers, because then with fractions you can do the LCM thing. You can add them together, or in other ways, another words I can say, it's very easy to convert all different number types into fractions. Uh, I'm not saying that we cannot convert to other number types, but fraction is easiest of all. That's why I call it, my best friend. Because we saw if we have a decimal, we don't have to do any calculation. We can just convert decimal into a fraction by using the same method, right? Like we talked about that.
Yeah.
And then fraction is a fraction. A whole number you can always put a one as a denominator that becomes a fraction, right? And with the mixed number, it's a simple that cyclic thing that we talked about that we can do for converting to a fraction. So our in any exam or in when we are trying to solve anything, when we are dealing with different types of numbers, an easier approach is to convert them to fraction. That way it is much easier to deal with. Yeah. And then we looked at the chicken egg theory, which is an extension of division, to see if we come across a point where the remainder is smaller than the number that we are trying to divide with. That is when we look at this chicken egg thing to go as far as we want to go. Yeah. That is all we have covered so far. Any questions, confusion, doubt, worries?
No, I think it's okay so far.
Yeah. Now, and See, while it might sound very childish for us to do these things at this point in time, but interesting thing is the entire maths that we learn all the way till PhD and postdoc and whatever, right? Depending on how far you want to go with maths, it revolves around those basic four operations: addition, division, multiplication, subtraction. And if we are not thorough with that, if we are not comfortable with that, if we don't know how to play with it, it makes our job a little more difficult. So that's why there's no harm in going back to the basics and making sure that we practice enough, right? Let's say, I mean, I can tell you in writing that no, if if you give something like this, anybody who looks at this kind of a sum will think that this is a difficult sum, but in reality, it is not. We think this is difficult because we get scared without doing it. And I'll be honest in saying that I have seen that scare even among students in the engineering college, because it's easy to learn the concept. People end up not practicing things enough, right? So if you don't practice, that is where this worry around doing calculation starts haunting you. But if you play with the operations, right? I mean, if somebody says, okay, fine, I'll tell you some trick. If you have to divide this number, okay, will we get a whole number or will we get a decimal? I want you to do it. Tell me without doing it.
Um,
I mean, if you know, I'll tell you some trick. That's why I'm asking this. I will tell that this is not possible. I will say that I'm not going to get a whole number by
no, it
dividing.
won't be a whole number.
I will not get the whole number.
No,
Why?
because the numbers don't add up to any multiple of 3.
Wonderful. That's one of the tricks. Okay. Uh, if I say by 9, will it give you a whole number?
No.
Same thing. 3 and 9 have the same behavior. You can use this as a trick if you have to do something with this, right? You have
Yeah.
to add up the numbers and see if that is a multiple of 3 or 9. That happens with 3 and 9. If you have to figure out, it's easy, right? I mean, you would not even worry about it. This is an odd number, so this will not give you a whole number. This is an even number, and this will give you a whole number, correct?
Yeah.
And how do you find out the odd number, even number? You just look at the unit place. If it is any of the multiple of 2 or 0, you're good. Yeah.
Okay.
Same thing, if you have to find out if this will be if this will give you a whole number, how will you know?
It won't.
But how?
Right, because the last 2 digits are not a multiple of 4.
Exactly. So 2 and 4 have similar behavior. 2 only looks at the unit place because that is more than enough. 4 looks at the last two place because any multiple of 100 that is divisible by 4. Okay. So that's why you don't look at the 100 place. You only look at the first two place, the units place, a unit and tens place. Now, anything is a multiple of 10, we don't have to worry about it, right? We don't really have to do
Yeah.
it. You know the magic. Now, 10 or 100,000, that we don't have to worry about. If something is divisible by 8 or not, how will you find it out?
Um, is it the same as 4?
No. So here's the thing. Okay. So always look at what is the smallest number in the place value that is divisible by number. Let's say if you are looking at, see, look at this. Unit place is enough. This is too small number. Any number to be divisible by 2, you just look at the unit place. That is more than enough. Because any 10th place is multiple of 2 by
Yeah.
default. If you're looking at 4, you're looking first 2 because you know that 100, the smallest of the three number 100, is a multiple of 4. So I will, if once it reaches 100, I don't have to worry. My worry is with the first two places. Same way, if you look at 1000, 1000 is the smallest 3 digit, 4 digit number, okay, which is divisible by 8. 125 into 8 is 1000. So in case of 8, you look at first 3 digits, okay, because if once you have 1000 or 2000 or 5000, everything will be divisible by 8. Don't have to worry about it.
Okay.
Your worry is with the first three places. So in summary, if you're looking at anything being divisible by 2, you look at only unit place. If you're looking at anything divisible by 4, you have to look at the unit and tens place. And if you're looking at divisible by 8, divisibility by 8, you look at first 3 digits because anything beyond that is taken care. Yeah.
Okay.
And these are the tricks because and we derive these tricks based on more and more practice we do, more and more we sums we do. Okay. So there's no book that will make it explicit. I mean, you might find it in some places, but uh, these are the derived theories that that we play with. Okay. And this is needed because it will help you with in a scenario. Let's say you have a sum to solve where it says, okay, 1 by 5 plus 2 by 9. The four options are 2.9, 1.6, 1.4, and let's say something else. And you would certainly not want to do the complete calculation to see which answer it is because this question might not give you enough time, right? In an exam, if you're looking at a 10 multiple choice questions, that the assumption is these are easy questions and they will allot you time according to the complexity of the question. So there's a lot of elimination thing that you will end up doing. Okay. So here by looking at this looks like okay, point 0.2. This is little less than 0.2, right? If this was 2 by 10, that was 0.2, but it was 2, it is 2 by 9. So this is little more than 0.2. So this is 0.2 and this is little more than 0.2. So we are talking about something in the range of zero point 0.4 to 0.5. That's it.
Okay.
This is not an option. This is not an option. This is not an option. So this is where you do a combination of mind math and this thing, and bit of rough work. This is 1 by 5.2. This is, if this was 2 by 10, that would have been 0.2, but this is 2 by 9, meaning it's a bigger piece. 2 by 9 is greater than 2 by 10, correct? Because here, the size of the candy that every kid gets is bigger than this one, right? So you know, okay, this is 0.2 and this is little more than 0.2. So anything which is closer to 0.4 is what should ring the bell for me. That's the option that I'll choose. These options are not relevant. I'll just eliminate them. So we end up doing a lot of elimination techniques. That's why these calculations that we do comes out handy and helps us do the things much faster. Okay. So that's why I was emphasizing on those, I call them baby tricks, but those are very much needed. Let me stop recording first.